and I'm going to show you exactly what we were talking about, okay? So, first and foremost, a rational expression is an expression written in the form P over Q. They use caps? Yeah, they use caps. Where P and Q are polynomials and Q cannot equal 0. All right? So some examples of what these look like. You can legit just have the fraction -5 over 4, which we've seen that before. But you can also have stuff like this. 4y cubed over 7, -7z over z squared minus z minus 6. Or you can even have the very complicated situation. 5x squared minus 3x plus 7 or plus 2 all over 3x squared minus 3x plus 3. Okay? You can have any one of these, all right? The fact of the matter is they are all considered to be rational expressions. Now, don't buy that. Don't bite that. That is not a toy. Thank you. We love you. Don't bite that. So these are all called rational expressions. And the fact of the matter is rational is just a very fancy word for like a fraction. Okay? Expression is just another fancy word for a mathematical statement. And if you recall from a long time ago in a galaxy far, far away, a rational expression is a fraction where it will contain variable terms, constant terms, and some math operations. Okay? Also, when we're looking at, let's say specifically the -5 over 4, you got to remember that negative really doesn't matter if it's in the numerator or to the denominator or if it's written out front right in the middle. All right? Traditionally, we will just put it out front. But it doesn't matter where it goes. It's all the same thing. All right? So, the first objective that we're going to actually look at is something that you already know. Like I said, a lot of this is just going to be a review. So, we're going to find a domain of a rational function. Now, I have a question for you. Can anybody remember what it means to find the domain? Now, we did this. Remember functions? Here, we'll go back. I think it was, chapter 10? Functions. Wow, look at this. Find the domain. We did one example there. Look at this. We found another domain. Let me scroll up a little bit. Write the domain. Okay. Where were the steps for this? I think they're right here. Identify the type of function. That's your first step. Your second step is to find all the contradictions. In other words, find the numbers that we know will not work inside of the function. For this specific example, we had f of x equals 1 divided by x minus 6. That is a rational expression, no matter which way you look at it. If I just get rid of this out front, boom, rational expression. And we know denominators are not allowed to equal 0. So we take the denominator, set it equal to 0, and find the x value that will give us that contradiction. So if I take x minus 6, set it not equal to 0, and solve. Notice we find that x cannot equal 6. This is our contradiction, so I'm reading over here where I just put this box. This is our contradiction. It is the number that is not in the domain. It is the number that if I put that into this special calculator that can only calculate 1 divided by x minus 6, the calculator breaks. It says error. And how do we write our domain? Well, we can write it in interval notation by kind of graphing it, putting a circle where the number 6 is, because we know we're not allowed to have that. And since I shaded on the left-hand side, the left-hand side is negative infinity all the way up to negative 6. And on the right-hand side, it's going to be 6 to infinity. And I use parentheses because I'm not allowed to include the... Did I put negative 6 here? Sorry, positive 6. I use parentheses because I'm not allowed to include the 6. And infinity symbols always get parentheses. Does that make sense, everyone? We did this all the way back in chapter 10. Today, we're going to do the same thing. Except instead of using very simple denominators, like the denominator we looked at, this was linear because the x is raised to the first power. That's linear. That's easy. In fact, chapter 10 is all about lines anyways. Today, what I want you to do is find a domain for h of x equals 8x minus 3, all divided by x squared minus 5x plus 6. Notice, it is the same exact question. It is a function in which I need to find a domain. The steps are: first, identify the function. Step 1. Identify the function. This is a rational expression. All right, and remember, rational means, or ratio, is just a fraction. So we know the denominator cannot equal 0. So in step 2, we're going to find the contradictions. Well, remember, denominator cannot equal 0, so you take the denominator. And we're going to say, well, we're going to make this not equal to 0. Okay? And then we're going to solve. So you have a quadratic not equal to 0, which means you got to factor. And how many times have we done this already, everybody? Too many times, am I correct? So how about 2 and 3? 2 and 3. So now I said each one of these not equal to 0. And solve. I find that x cannot equal 2 and x cannot equal 3. In other words, I can use any number I want in this function h of x. I can use any value I want. The only two that I'm not allowed to use are going to be x cannot equal 2 and x cannot equal 3. Okay? Now, step 3. We're going to write out the domain. Okay? I'm going to do this 2 ways. First, we'll do it the traditional interval notation, and then I'm going to show you another type of notation. And then the additional type of notation is the new thing here, okay? So here's interval notation, and it always helps by drawing that number line. So I'll put 0, 2, 3, and I put holes at 2 and 3 because I'm not allowed to use them. And what I'll do is I'll highlight where I am allowed. So I did that in green. Are we all on the same page so far? Are we all on the same page so far? All right. So directly underneath, I'm going to write the interval notation. Here's my first interval, letter A. Letter B is my second interval. And letter C is my third interval. So I actually have 3 of them here. I go from negative infinity all the way up to 2. Then I put my union symbol. I go from 2 to 3. Then I put my union symbol. And I go from 3 to infinity. And all I did underneath is, as I just said, okay, this is the interval for part A. This is the interval for part B or segment B. This is the interval for segment C. All right? Now that's called interval notation. The new notation that I'm going to teach you, is called set builder notation. Now, set builder notation is exactly what it sounds like. It gives us a set and it tells me how to build it. All right, so they want a set and it tells me how to build it. And this is easy. You will always, always, always have this setup right here. You will always, always, always have this setup where you have a squiggly brace, the letter X, and then that vertical bar. I'll tell you what that means in a second. And then leave a big space and then end the squiggly brace. Now, what goes inside of this big space is going to be the contradictions. Okay? So, you know what? You might leave yourself a little bit more space. And this is how you will always write it. It's very simple. You will always write it as X is a real number. Okay? And X cannot equal 2, comma, or the word and. X cannot equal 3. So you tell me X can be any real number and X cannot equal 2, X cannot equal 3. That's the contradiction part. Maybe I'll be a little bit more specific with that. All right. So I will highlight all of the stuff that every single one of these will have. Like you should always have this. The only thing that's going to change from problem to problem is going to be the contradictions that you find. Now, this vertical bar is red is such that. That's what that vertical bar means. Okay? That's what the vertical bar means. So when I read this, I read it as X is such that X is a real number and X cannot equal 2, X cannot equal 3. All right, are there any questions there? Okay, so there's objective 1 done. Finding domain, we should already have a pretty good understanding on how to do that. All you're going to do is take the denominator, set it equal to 0, and then solve and then tell me what the contradictions you found were. Here's something that you already know how to do. This is objective 2. Now we're going to simplify rational expressions. And we're going to start off with something very simple. We'll start off with something very simple. Let us divide, or better yet, let us simplify the fraction 15 over 65. Now, Eunice, I remember you and I having a conversation about this. A long time ago, we were talking about fractions. And we were talking about how to simplify them and when do you know you're done. And I gave you a technique where I said, all right, well, let's write out the prime factorizations of these two numbers. And I said, once you write out the prime factorization, think about what I'm saying there. Prime factorization. I'm factoring a number, and I'm using prime numbers to do that. So once I write this prime factorization, I can see that the 3's will reduce. No, I'm lying to you because my prime factorization is incorrect. Somebody should have yelled at me there. Sorry. 65 is 5 times 13, not 3 times 13, floater. So here, I could clearly see that the 5's reduce because 5 over 5 equals 1. So this turns into a 1 and that turns into a 1. If I clean this up just a little bit, I can see 3 times 1 is 3. 1 times 13 is 13. So I just simplified my fraction. I did that by prime factorizing. Now, if you had me for 80, you would know how to do that because that is the method I stress. There are other methods. Eunice, this is where you and I had this conversation. Because I think with a problem like this, you would have said, well, couldn't I just divide the top by 5 and the bottom by 5? And I would have said, yeah, absolutely. That's the shortcut method. But if you write out but by me forcing you to use the prime factorization, especially when I taught it, now you have a really good understanding on how to do a problem like this. So if I asked you to simplify, which means to reduce, in order for you to do this, you got to know how to factor. You got to know how to factor. This entire chapter, we're factoring all over again. So, and because we already learned 13, I'm going to speed up the factoring process a little bit. So, in the numerator, difference of squares, x plus 3, x minus 3. Denominator, trinomial with a 1 out front. I can go right into the parentheses, put an x, copy it on the first sign. The second symbol has to be a minus. There's no ifs, ands, or buts about it. And this is going to be x plus 3 times x minus 2. Now, if you look, and I will highlight, notice we have the binomial x plus 3 in the numerator and the binomial x plus 3 in the denominator. That will reduce to a 1. And last time I checked, 1 times x minus 3 equals x minus 3. Come on, get out of here. And 1 times x minus 2 is x minus 2. And we just successfully simplified our first rational expression. Does that make sense, everyone? So, did I teach you anything new? Not really. I'm just combining everything that you've learned, and now we're putting them in the problems. All right, let's try another example where we're factoring. Five z to the fourth divided by 10z to the fifth minus 5z to the fourth. And we're going to completely simplify. You gotta let me know if I'm moving too fast, because I can rip through these problems. So you gotta let me know if I'm moving too fast, okay? Excuse me. All right, here we go. The numerator, already, it's just one monomial. There's nothing I can factor there. So I leave it the same. Now my denominator, I look for a GCF. I definitely see one. It's 5z to the fourth. And when I factor 5z to the fourth, I get 2z minus 1 left over. Okay? Now, in the numerator, I got a 5z to the fourth. And in the denominator, I got a 5z to the fourth. I'll highlight them so you can see them, so you know what I'm talking about. So I can definitely reduce them. So when I reduce them, the numerator becomes a 1. The denominator becomes a 1. And if you really think about it, 1 times 2 minus z, or did I say 2 minus z? 1 over 2z minus 1 times 1 is just 1 over 2z minus 1. So these will reduce. Are there any questions? Okay, let's keep going. The next one is 3 plus z divided by x plus 3. Now, I will give you a little guide here. You're always going to want to try to write your numerator polynomial and your denominator polynomial in descending order. It just helps. So the first thing I would do is rewrite this numerator as x plus 3 over x plus 3. I'll put this in a different color so you know that's what I did. And hopefully from here you can see that x plus 3 over x plus 3 is the same exact thing as 5 over 5 or 8 over 8 or 2 over 2, which is 1 over 1 or 1. Now, I'm not trying to trick you or anything. That's just, this happens sometimes. Now, where this try to write in descending order really kicks in, where it really helps us, is a problem like this. Okay? Can you guys hear Artie tearing up a bag behind me? Stop. He doesn't listen to me. All right, so the numerator, we got to rewrite that. So let's rewrite the numerator in descending order. And you're going to see what happens here. Hey, buddy. Hey. Here. Play with your squeaky toy. Look at this. Look at this. Isn't this nice? Look at it. All right, so negative x plus 5 over x minus 5. Now, if I really take a step back and just look at this, in the numerator, the x is negative. In the denominator, it's positive. Opposites. In the numerator, the 5 is positive, but in the denominator, the 5 is negative. Opposites. So you could look at this one of two ways. You can, in the numerator, you can factor out a negative 1, because remember, factoring out a negative 1 switches signs. That's all it does. So now that we see x minus 5 in a numerator and x minus 5 in a denominator, we know that's going to reduce to a 1. And negative 1 times 1 is negative 1. So that's one way you can look at this. The other way is if you can recognize from the very start that the x is negative in the numerator, the x is positive in the denominator, the 5 is positive in the numerator, and the 5 is negative in the denominator. If you can recognize that it's completely opposite on numerator and denominator, then what's the opposite of 1? Negative 1. So you could kind of save yourself a little bit of writing if you can recognize it. If not, factor out that negative 1. Personally, I would factor out the negative 1. I would show that because that's just me. I don't like to take too many shortcuts in math. I like to write everything out. Are there any questions? So far, so good? All right. 13.1 is done. Or sorry, I said 13.1. I meant 14.1. 14.2. This is going to be a really dumb question because I'm going to guess that nobody remembers. But when you were learning fractions, the first thing you were taught is how to simplify. Does anybody remember the next thing you were taught? No, that's fine. Like I said, I'm not expecting too many to remember. So when you learn fractions, you were taught to simplify first. When we learn rational expressions, we're taught to simplify first. When you learned fractions, you were taught to multiply first. Actually, multiply and divide. And we do the same exact thing with rational expressions. So we're going to learn how to multiply and divide rational expressions. And what's beautiful about this, if you already know how to multiply fractions, you already know how to do this. Okay? So let's go ahead and let's look at this. So recall, zoomed in way too much. 5 over, let's say, 21 times 7 over 10. So when you were taught how to multiply or divide fractions, depending on your professor, if you had me, you did it a way. If you had another professor, it was another way. I will not fight you on this. You could do it however you want. But if you had me, you will see why I showed you the way I did. Okay? So if you had me, and I'm going to review this for everybody, to multiply fractions, you always want to simplify first. Then, part 2, you're going to multiply or divide from left to right. Okay? Now, I'm going to be honest with you. And please, you don't have to write this down. But if you wanted to, you could take 5 times 7 is 35. 21 times 10 is 210. And then you'd have to simplify this. All right? Then you would have to simplify this. That takes some time. Here's what I show. When we talk about simplify, I'm talking write the prime factorizations of each number, or just write out some numbers that multiply to get that. For example, 5 is prime. 21 is 3 times 7. 7 is prime, and 10 is 2 times 5. Now, from here, I look for numbers that are the same on a numerator and denominator, and that's because I know eventually they're going to equal 1. 5 over 5 is 1. 7 over 7 is 1. 8 over 8 is 1. Okay? So if you look here, and I'm going to highlight different colors. So 5 and 5. So that's going to turn out to be a 1 when I simplify. I don't know what just happened here. I don't care about Spotify. And 7 over 7. I mean, that turns into a 1 as well. So I get 1 over 3 times 1 over 5, or the answer is 1 over 15. And I know that is completely Did I say 1 over 15? I am making way too many mistakes today. The answer is 1 over 6. I need to slow myself down. So let me take a breath. I need to take a deep one. Feel better. Now, I know the answer is 1 over 6. And I know that is completely simplified already. And it's because I did it first. So, I'm not going to fight you. If you just want to do this your way, that's fine. But when I taught how to simplify fractions all the way back in chapter 4 in MAT090, I showed you how to factor it because we're going to now multiply rational expressions and you have to factor them first before you can do anything. Does that make sense? All right, let me show you an example of what I'm talking about. All I want you to do is just watch me for right now. Here's an example, okay? I'm going to leave the 5 over 7 thing, right above us. So when I approach this problem, the first thing I'm going to do is simplify. And to do that, I'm going to factor everything. Okay? Second, I'll just multiply, which I'm just going to rewrite what's ever left over. So the x minus 3. There is no GCF. It's a binomial, but I can't factor anything, so I just rewrite it. The x plus 5, same as the x minus 3. There's nothing I can do about that. Now, that 2x plus 10, definitely a GCF. So I factor out a 2. And the x squared minus 9, that's a binomial difference of squares. X plus 3, x minus 3. So now that I've factored everything, I'm going to simplify. Now I'm going to look for things that are the same in the numerator and denominator. That occurs right here. You got those two. And you got those two. So what ends up happening here, everybody? Now give me 1 second. Because I want to copy and paste this real fast. Because I want to show you what happens. So now I got to scroll up a little bit. All right. So what happens here is these reduce. So I'm going to make sure I really scratch them out. X minus 3 over x minus 3 is a 1. And then x plus 5 over x minus 5 is a 1. Or x plus 5 divided by x plus 5 is still 1. So if I clean this up, the first fraction turns out to be 1 over 1 times 2 over x plus 3. And last time I checked, 1 times anything is just itself. And there's our answer right there. So if you remember how to multiply fractions using the prime factorization method, you already know how to do this as well. All you're going to do is factor everything first. Okay? Are there any questions with that? Are there any questions? All right, so I'll give you a minute to write that down. Hey, I got a question for those of you in the room. If you didn't have me for MAT090 or whatever, were you taught the prime factorization method for simplifying fractions, or were you taught like the shortcut, like, oh, they're both even, so divide them by 2? You were taught the prime factorization method? Okay. At least Courtney's let me know the truth. She's saying no.
I mean, It was like 11 years ago for me though, but
That's okay.
I just did like the cross simplifying.
Yeah. Yeah.
How I remember.
Yeah. That's a very quick and efficient method to simplify numbers very quickly. But that doesn't help you here. All right. Are there any questions? Because if not, I'm going to write out some steps and then we're going to do some problems. All right. So I'm going to scroll up halfway. So to multiply / divide, doesn't matter. Rational expressions. Step 1. Rewrite the problem if necessary. Okay? Now, what do I mean by that? What I'm talking about is descending order. Or if you're dividing. Okay? Because remember, dividing, you actually rewrite the first fraction, division changes the multiplication, and you reciprocate the second fraction. So if you need to, rewrite the problem if necessary. Don't worry, we'll definitely do that today. Step 2. Completely factor everything. Step 2 is the most important step. You got to make sure you completely factor everything. Okay? And then step 3. Simplify by dividing out factors. All right, that's that. 2 over 2 is 1. Or x plus 1 over x plus 1 is 1. Like, you got to be able to see that. Okay? All right, so we're going to start off with a really easy problem. This one, you would have already have seen at the beginning of the semester for this one. So, example, and I'm just going to put the words multiply for all of them, okay? All right, so we have 25x to the second divided by 2 times 8 divided by 5x to the fifth. So, first thing I would do here is I would write everything in order because that's me. So watch what I do. If you just want to watch, I'll give you some time. 8 times 25 times x to the second divided by 2 times 5 times x to the fifth. Because remember, you multiply fractions from left to right. But notice, I didn't multiply anything yet. I just rewrote it. That's it. Now, that 8 is 2 times 4. That 25 is 5 times 5. And what happened there? And I'll leave the x to the second as x to the second. In my denominator, 2, 5, and x to the fifth. Nothing happens there. Now, all I'm doing is rewriting the problem. And that's because I'm going to look for terms that are the same in the numerator and denominator and just divide them out. So if you want to, just watch what I do. Everybody watch the screen so you don't miss something. So I'm going to go from left to right, and I'm looking for numbers that are the same in the numerator and denominator. 2 over 2 reduce. 5 over 5 reduce. So far, and I'm really doing each little step. So far, you have 4 times 5, which is 20. X to the second over x to the fifth. Now, we know that if the bases are the same and you're dividing with variables, you subtract the exponents. So this is going to be 20x to the negative 3 or 20 over x cubed. And there's your first example done. So like I said, very easy one. You already knew how to do this one. You did this problem when we learned rules for exponents. So that would have been like what, chapter 12 or something like that? Are there any questions? All right. So while you're writing that down, I'm going to get the next problem set up. So this is problem A. Here's problem B. All right, how are we looking so far? Okay. So let's scroll up and let's do this problem. Now, hopefully you have your steps. Step 1, you're going to rewrite stuff. Make it look easier for yourself. If you need to, rewriting in descending order always helps. If you're dividing, apply the rules for division. Here, I definitely see some things that I can rewrite. So that's what I'm going to do first. I'm going to rewrite the numerator as negative 3x plus 6. And I'll rewrite the denominator as 6x squared plus 6x. That's just me. Now, step 1 is done. So I guess step 1, maybe I should be writing out these steps. Step 2, now I'm going to completely factor everything. The easiest way to do this is start in the upper left-hand corner of the fraction and just do it one by one. So for the first fraction, the negative 3x plus 6, I can factor out a negative 3. That's going to give me x minus 2. So far, so good, everyone. Now, the 6x squared plus 6x. I could definitely factor out a 6x. And that's going to give me, excuse me, x plus 2. Any questions so far with what I've done? Okay. Now.
Would that be 1?
What do you mean?
I'm confusing myself over here.
No, it's not 1. X minus 2 and x plus 1 are different. Okay. All right. Now, for the second fraction, the 3x squared minus 2x minus 5, I'm going to wait for that. I'll wait to do that one because I see the x squared minus 4 in a denominator. I see this. And boy, I love seeing that because that's a difference of squares. X plus 2 and x minus 2. Okay? Now I will factor the 3x squared minus 2x minus 5. In other words, I'll save the hard stuff for the end. All right? So that is a trinomial. It's a trinomial with a not equal to 1, which means AC method. So let me just write it here. This is going to be my scratch work. And like I said, I'm just going to speed this up a little bit because we already done this. We've already been testing on it. So step 1, let's get an idea. It's going to be a minus and a plus. Step 2 is 3 times 5, which is 15. 1 and 15, 3 and 5. I need them to combine to give me negative 2 in the middle. I know one of them's negative, one of them's positive. So plus 3 minus 5 is negative 2. So then I'm going to rewrite this. It's 3x squared minus 5x plus 3x minus 5. And the reason why I chose to write it like that is I have the positive in the middle now. Because when I go ahead and group like terms, did I just say group like terms? When I go ahead and factor by grouping, I don't have to worry about sign changes. So the first grouping, I can factor out an x. The second grouping, there's nothing I can factor. But I'm a happy camper because the binomials inside the parentheses are the exact same. So I'm left over with 3x minus 5 times the quantity x plus 1. And that's exactly what I write directly above my x plus 2x minus 2. So 3x plus 5 and the x minus 1. All right, are there any questions so far? So, if I can give you any advice on doing this, okay? If I can give you any advice on doing this, it's going to be all about factoring. You got to factor everything. All right? Are there any questions so far? All right. So, step 3. Oh, not a B. This is where we're going to reduce, all right? Personally, I don't care how you do this, but I do try to make this visually as easy as possible for myself, okay? So, what I mean by that, okay, no, we're just going to keep moving from here. Because I do have a mistake. There is a mistake on the board, I can see it. But since nobody called me out on it, I'm just going to wait. I definitely see a mistake here. It is my bad.
The x plus 2.
Which should it be?
Or 1. That's
Yeah.
what I was trying to ask, but I got myself confused.
So here's my mistake right here. When I went to factor the 6x squared plus 6x, you could definitely factor out a 6x. I wrote x plus 2. It should be x plus 1. Now, here's the beautiful part about this. When you do these problems, you will definitely be able to simplify some things. Okay? So make sure you're aware of that. Now, here's what I'm going to do. Watch. Somebody tell me what I did. I'm just going to write it. Somebody tell me what I did here. Can anybody tell me what I did there?
Just lined them all up.
Why did I do that?
Get easier.
And what math property allows me to do that?
Oh, I don't remember.
I'll give you a hint.
Okay, I got my note.
I'll give you a hint. 5 times 4 is 20. 4 times 5 is 20. Does the order matter when you're multiplying? You remember the name of that property? Starts with a C. All right. I'll help you here. It's the commutative property. Commutative. Remember, when you're multiplying, x plus 1 times x minus 2 is going to be the same exact thing as x plus 2 times x minus 1. The order doesn't matter. So the only thing I did is I rewrote the entire numerator and I rewrote the entire denominator so things that are the same are on top of each other. And the reason why I did that is so I could easily simplify. So I'm just going to copy and paste this. All right, let's do the easy part first. I'm going to highlight the things that are the same, because I know these will divide out evenly. So I know I'm going to eventually cancel them. And I can reduce that up front too as well. All right, so let's take this one step at a time. Forget about that negative for right now. What's 3 over 6 as a fraction reduced? What is 3 over 6 as a fraction reduced? And if there's a negative out front, Jay, then it's just negative 1/2. Would you agree?
Yep.
All right, so let's write negative 1 over 2. Now, the next thing is that letter x in the denominator that's next to the 6. Nothing reduces that, so I write an x. Now, the x plus 1 over x plus 1, we know they cancel out, or they divide out. The x minus 2 over x minus 2, they divide out as well. So it looks like the only thing left over in the numerator is the 3x plus 5, so times 3x plus 5. And the only thing left in the denominator is x plus 2. And if I just clean this up just a little bit, 1 times 3x plus 5 is just 3x plus 5. And leave the denominator factored. Because remember, you're reducing, so you want everything to be simplified. So our final answer is going to be 3x plus 5, or I'm sorry, negative 3x plus 5 over 2x times a quantity x plus 2. Now, I know this may seem like a lot. Excuse me. But we didn't do anything new here. Like, I didn't teach you any new trick or any crazy thing. We factored and then we reduce, just like you did in chapter 4 when you learned fractions. So let's do one more example for today. I showed you a couple multiplications. Now I will show you a division. And I'll keep this one simple. So we're going to divide 10x minus 2 over x squared minus 9 divided by 5x squared minus x all over x plus 3. All right, so step 1, rewrite if necessary. So I kind of look real quick. I see that all of my polynomials are already written in descending order, so that's good. However, I'm dividing. So you got to recall to divide fractions, you rewrite the first. Division changes the multiplication. And you reciprocate the second fraction. So it's going to be x plus 3 over 5x squared minus x. Okay? Step 2. We completely factor everything. So in the first fraction in the numerator, I can factor out a 2. That's going to give me 2 times 5x minus 1. In the denominator, difference of squares. X plus 3 times x minus 3. For the second fraction, the numerator x plus 3 does not factor. There's no GCF or anything. And then for the denominator, the second fraction, I can factor out an x. Okay, and that's going to give me 5x minus 1. Step 3, and this is just me. I like to rewrite everything so it's nice and neat. So I'll put 2 times x plus 3 times 5x minus 1. And then in my denominator, I'm going to write an x times x plus 3 times 5x minus 1 times x minus 3. I just try to line things up. That's it. Like I said, if you don't want to do that step, you don't have to. You just better make sure that when you simplify, you're simplifying everything correctly. Somebody have a question? Okay, I thought I heard somebody unmute themselves. All right, so let's just go from left to right. The numerator 2, nothing in the denominator simplifies that. The denominator x, nothing simplifies that. Now, before we move any further, I want to make sure I make this abundantly clear. That x is outside by itself. The x plus 3, the 5x minus 5, think of those parentheses as like bear hugging, meaning both of those terms, the x plus 3, they're together. They come together. They're like glued together. So the parentheses, even the plus sign, glues all of that together. So I cannot, and I need to stress this, I cannot do this. Watch, everybody watch. This move right here is bad news bears. You cannot do that. You just can't go inside parentheses and start picking things out. Okay? All right, so nothing reduces the x in the denominator. Now, the x plus 3 in the numerator, x plus 3 in the denominator. The 5x minus 1 in the numerator, 5x minus 1 in the denominator. Now that everything is reduced, I just write whatever's left over. In the numerator is a 2. In the denominator, it's x times x minus 3. All right. Are there any questions? Any questions whatsoever? Okay, then. Well, that's going to be it for today.